Hello and welcome. We are going to cover the part 4 of chapter 1 in this video, and the topics covered are density and classification of matter. Density is one of the parameters that is going to be useful, especially in the identity or trying to identify matter. So the property of matter that is used as an identification tag for substances. Density of a liquid can be determined easily by weighing an accurately known volume of liquid. For example, a chemist trying to identify an unknown liquid finds that 25.00 cubic centimeter of substance has a mass of 19.625 grams at 20 degrees Celsius. So using that, we can determine the density and compare that with known values that are reported in the literature. So here it gives you some of the substances with their density, like chloroform. The density is 1.492 grams per cubic centimeter at 20 degrees Celsius, and so on. So which of these compounds is the most likely to be the unknown liquid? So again, we do a calculation based on what we have previously carried out. Now, what is the relationship for density? So in this, density is a mass over volume. Mass generally is in grams and volume in cubic centimeter or milliliters. So substitute in the values: 19.625 grams divided by 25.00 mil or cubic centimeter, and that gives the value of the density. Now, if you're working with significant figure, you will see that we have maintained a 4 significant figure, which is the least of the two. This density corresponds exactly to isopropyl alcohol, which therefore most likely to be the unknown liquid. However, note that the density of ethanol is also very close. And to be sure that the compound is isopropyl alcohol, we should run several more density experiments. And this gives you the value of densities ranging from gas substances to solid. And you will notice that the gas are generally very, very low in terms of their density, followed by the liquid. And then solids, you'll see that they are generally much higher in the value of the density. Matter can exist in the 3 states that are listed here: solid, or liquid, and gas. The definition of matter in general is anything that has mass and occupies space. So consider, in this case, solid. Solid is rigid in its structure, has a fixed volume or shape, and very incompressible. In other words, the rigidity is pretty firm in a solid. And in the liquid, it fills a definite volume, no specific shape, assumes the shape of a container when it's poured into, and slightly compressible. And you can see here, locating the depicting the structure of the liquid, in this case water molecules, and seeing that the difference in terms of the spacing between the individual water molecules is a lot narrower compared to that of a solid. And then for gas, there is no fixed volume or shape, and takes the shape of the container that is existing, and highly compressible, and relatively easy to decrease the volume of gas. And here you're looking at the volume. You can see that the molecules of gas occupies the entire volume in which they are present. Now, in terms of mixtures, when we are looking at matter, it can be in terms of different compounds or elements in the mixture. But what is common in the mixture is that it has a variable composition, and generally there are two types: homogeneous or heterogeneous. Homogeneous has visibly indistinguishable parts and is often called solution, whereas for heterogeneous have distinguishable parts. And mixtures can be separated into pure substances by means of a physical method. In physical change, as opposed to chemical change, this is where change in the form of a substance, there is no change in the chemical composition of the substance. For example, in the boiling or freezing of water, there is no breaking of the compounds into elements. That's a physical change. Now, in the physical change, physical process in the separation of mixture, there are three that we will generally start off with, and these are distillation, filtration, and chromatography. In distillation, the separation is by the boiling points of the various components in the mixture, which is a measure of their volatility. The boiling point is related to the volatility. The lower the boiling point, the more volatile the compounds are. The vapor is passed through a condenser where it condenses back into a liquid state. So in the distillation setup, once you vaporize and then reform or condense the gas into liquid, that is done in the condenser. In the one-stage distillation, which is often a simple distillation, when a mixture contains several volatile components, a one-step distillation is often not sufficient to do this. So to separate a complex mixture, you may need a more elaborate setup. Now, this is a simple distillation apparatus, and you will need a flask or container that will contain your liquid, and that is heated to boiling, where it is then allowed the gas to pass through the neck of the flask to the condenser. So this long tube here with connections to the flow of cooling water is known as the condenser. So condenser will let the vapor that passes through to condense as a liquid, and then it can be collected here in the flask. So by monitoring the change in temperature, one can identify the components that is being distilled out of the mixture. The other technique is filtration. Filtration uses the different states of mixture. For example, if there is a liquid and a solid, you can separate out by filtration through a permeable, semi-permeable membrane. So the mixture is poured into the membrane, such as a filter paper, and passes through it passes the liquid through and leaves the solid behind. The third one is chromatography. This is a more sort of sophisticated technique that we often use in the a lot of analytical methods of analysis in chemistry and other subjects. What it means is that you have a mobile phase and a stationary phase where the mixture is passed through. Now, depending on the affinity of the various components of the mixture to the stationary phase, that will give rise to the separation or the differentiation of the different mixtures within that process. Separation occurs because the components of the mixture have different affinities for the two phases. They move through the system at different rates. Components with a high affinity for the mobile phase will quickly go through the chromatographic system as compared to one with a high affinity for the solid phase. Paper chromatography uses a strip of porous paper for stationary phase and a moving liquid as it passes, flows through the paper is the mobile phase. And this illustrates a very simple setup of chromatographic separation. A dot of mixture of ink is spotted just above the liquid level and left to stand, and after a few minutes this is going to be what is the result. So here the ink is separated into the various components of the color that constitutes that ink. So this is a paper chromatography. Pure substances, either compounds or free elements. Compound substance with a constant composition can be broken down into various individual elements via a chemical process, whereas element substance cannot be broken down into simpler substances by physical or chemical means. So in terms of the summary, matter can be into whether it's a pure substance or mixtures. If it's a mixture, it can be either heterogeneous or homogeneous type. In pure substances, it can be either pure compounds or pure elements. Now, the pure compounds can be broken down chemically to pure elements, and then elements is broken into individual atoms if we want to look at the detailed structure of each element. Now let's look at the classification of matter. A solution is also A. Here the choice will be B. A solution is also a homogeneous mixture. So in summary, the density is used for the identification of compounds or elements, and density is given by the formula mass over volume, mass in grams and volume in cubic centimeter. Matter occur in three states: solid, liquid, or gas, and mixtures have different components that can be separated by a physical method. The separation methods are distillation, where you separated by the mixture is separated by the different boiling points. Filtration, separation by the solubility or states, with a solid and a liquid, for example. And chromatography, separation by different affinity to the stationary and the mobile phase. So that concludes our part 4 and also the presentation on this series for chapter 1. Thank you.